We're going to look at a subgroup of line integrals, ones that look like this. So it's a line integral over a curve C of a vector field F, dot product with dr. And this is essentially the formula that you use to convert this thing into an integral in a single variable integral with respect to t. You take the function f and you replace everybody by t using the parametric equation of the curve C. You then do a dot product with the derivative of the curve C in its parametric form dt. So let me show you how that would work. Right, take this example here, just a made up one. So this here is our vector field, right? At any given point in 3D space, x, y, z, if you plug in a number here, here, and here, you will get a vector point, right? So it's like a huge 3D vector field. Passing through that vector field is a space curve, t squared, t cubed. So you can imagine a little bent piece of wire going through the thing. And we're going to find the dot, the line integral passing through this C. So how do we start? Well, the first thing we do is we convert this guy, which is him, and we convert them all into t's. And we use these guys on your curve. That's basically who the curve is, right? You give the parametric equation of the curve. In this case, x is t, y is t squared, and z is t cubed. And you use it to turn all these three guys into t's. So t squared, is just t squared, right? X add y is that plus that. And y minus z is that, take away that. Are you comfortable about how you take this fella and use the information given here to convert it into t's? Are we good? Now, we need the derivative. Well, the derivative from Calc 3 of this space curve is 1, 2t, 3t squared. Oh, and by the way, we need an interval for this, so let's do 0 to 2. So I'm ready to put all the package together then. So this fella is going to become the integral from 0 to 2. This fella, which is him, t squared, t plus t squared, take away t cubed, dot product, this guy dt, 1, 2t, 3t squared, dt. Okay, let's see what that looks like. The integral from 0 to 1. Dot products. This guy times this guy, so that's t squared. Plus this guy times this guy, 2t squared plus 2t cubed, that's that one. Plus this guy times that guy, that's 3t to the 4, take away 3t to the 5, dt. So the original has now just turned into a single Calc 2 integral with respect to t. I got this guy, 3 of them, so that's 3t squared. I got this guy, tt cubed. I got this fella, and finally I've got this fella. So not much, but I tried my best. Collect like terms. Power rule, t cubed, 1/2 t to the 4, t to the 4 minus 1/2 t to the 6. 2, 4, 8, 2, 2, 4, 8, 2, 4, 8, 16. 2, 4, 8, 16, 32. Oh, that is so cool.
Shouldn't that t to the 4 be 3/5 t to the 5th?
Oh, that was such a nice answer. Yes, it is. That's going to screw this one up totally now. 2, 4, 8, 16, 32, 64. 3/64 is 192/5. So I have 192/5. Instead of a really pretty answer, I'm going to a really ugly answer.
When the school is back open, you should go hang out in the math help area.
I missed that one.
Oh, no, I was telling whoever was talking last, you should go to the math tutor place and help people when everything's open again.
Okay. So I get 22 and 2/5, so it's at 111/5. I wish it had been the other answer, because then I could have said something. Do you know it's okay to get 0 for a line curve? It's also okay to get negative. But these particular line integrals are very often used to calculate the work done. So can you imagine you had a vector field F and you've got a curve passing through it? Then the work done is represented by this number. But if this number was 0, you'd be in balance. In other words, the energy, or whatever you want to call it, the work it took to move it, you get it back at the end. So it's totally balanced. It's kind of cool.
We use that equation all the time in physics.
For this thing? Have you, this is very interesting then. Have you, those who do the physics thing, have you actually seen this thing before?
We just introduced it like last week.
When did you see it again?
Like last week.
Cool. Do you see there is a little overlap? Do you do the dot product and all the stuff that I've done? You are going to find this last part of this dead easy, because you already have been doing it, right? For the rest who've never seen it, we still have to do them, right? Because they do need to see it. Okay. So do you get into, did I screw up, or was it a valid thing to say that if the work done was 0, the thing was in some kind of balance? Do you just calculate it and make no reference to what it looks like?
Well, we're currently learning it with respect to other forces such as gravitational potential energy and the kinetic energy and spring constant, spring potential energy. So
Okay.
I'm not quite sure.
Okay, that's fine. I just don't want to say something and then the physics guy laughs at me and said, did you say that's what that meant? You know, whatever. Okay, so let's look at, pretty much can do any of these guys. So I'm going to show you how question 9 is written down. That part is pretty standard, right? That's not the issue. They give you the vector function x, y, z, and they give you as the xi, the yj, and the xyk. I would call that x, y, and xy, right? I make too many mistakes, and I make fewer mistakes when it's written that way. Now, the space curve is exactly the way you'd expect it to be written. Well, first in the notation, the ijk notation. But the way I would write it, and the way I intend to write it, is like this. So I prefer this notation rather than the ijk notation. just to be consistent, I'm just going to use this notation all the time. So for the rest of today, when I do questions, they may be written like that in the WebAssign, but that's what you're going to see when I start doing them. In this particular question, you're also given t from 0 to pi. Okay, so bearing that in mind then, this would be kind of the working that I would be doing. Going to turn this guy into t's using the space curve. So this guy is just x, so that means it's just equal to sine t. This guy is y, which means he's just cosine t. And this guy is xy, which means he's sine t times cosine t. R dashed of t is going to be cosine t, negative sine t, and 1. And so that when you do the integral in this format, it now becomes the integral from 0 to pi, the dot product of these two guys. So this guy times this guy gets me sine t cosine t. This guy times this guy gets me negative sine t cosine t. And this guy times this guy gets me plus sine t cosine t dt. These two cancel out. And I am now looking at that guy, right? There are two totally different ways to do this. Both work. Tell me either of them.
U sub.
Who are you going to use?
Technically, you could use either one.
Yeah, okay. Both work. There is a totally different way from U subs. Also works.
I guess you could do integration by parts. That's a lot more work.
Okay, there are 3 ways to do that. I wouldn't choose to do that, but that's fine. I'm not sure. I think you end up in an infinite loop, that one. Identity. There is an identity that is equal to. No. The sine of 2t is 2 sine t cosine t, so half of sine 2t is that. Anyway, basically dot, 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 right? Find whatever method works, get the answer. Are we cool with that? And that's, by the way, that's question 9, right? Where else we left? Oh, according to the answers I've got here, the one I just finished, question 9, is 0. So you do get 0 sometimes. Next one, not so easy. I'll start this one off, I won't finish it. Here is our vector function, our vector field. And it's x squared xy, so it's a 2D field. And the curve C is actually that guy. Which is a circle. Which means that I need to create the parametric equation of this, and the x parametric will go here, comma, the y parametric will go there. How do you parametricize a circle?
R cosine.
Right, so how about 9 cosine theta? Well, I guess we'll stick to t's. T and 9 sine t, right? So 9 cosine t, comma, 9 sine t. And won't the f then now become x squared, which is this guy squared, which is 81 cos squared t, and won't xy be this guy times this guy, which is 81 sine t cosine t? And won't r dashed be negative 9 sine t 9 cosine t? Differentiate. And if you put that package together, you will get this guy times this guy, which is 729, I believe, sine t cos squared t, plus 729 sine t cos squared t. And I didn't realize it was going to be that nice until I did it. What is that?
0.
And isn't the integral of 0 0? Can we just pretend for a minute that it was just that bit, right? You added them together and you get some weird guy like that. What, which is what I thought was going to happen. What technique will I use to integrate this fella?
U sub.
Yeah, and who should the U sub be? Because only one of them works this time.
Sine.
Cosine, correct. So dot, 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 because the answer is 0. Are we good? So the next question is, well, the next bunch of questions are all going to be find the work done. And when you get a find the work done, you're going to be told a vector field, you're going to be told an r of t, and you're going to be given some t values, right? And the work done is the line integral is that guy. So it's the same guys we've been doing, they're just calling it the work done now. So who shall I pick? Let's do a version of question 12. The vector field is x take away y squared, y take away z squared, and z take away x squared. And the curve C is defined as the line from the point 0, 0, 1 to 5, 1, 0. Okay, so our question is find the work done in traveling through this vector field from this point in a straight line to that point. What do you think I need to do first before I can even start doing this?
Find the R.
Yeah, I've got to find the equation, right? Would you agree this one is pretty straightforward because we've already talked about this before, but just to remind you, don't you find the direction vector v? And in this case, 5 take away 0, 1 take away 0, and 0 take away 1. And I believe I called that, if I keep to my notes, didn't I call that ABC? And won't the x and the y and the z, the parametric equation, be x naught plus at y naught plus bt and z naught plus ct. Remember that? In this case, 0 plus 5t, which gets you 5t, and 0 plus 1t, which gets you t, and 1 minus 1t. So we now have the parametric equation. I guess I could put it here. And it's going to be 5t, a t, and a 1 minus t. Are we okay with that? Right. I'm going to squeeze in here what the derivative looks like. And there's something really weird about the derivative. It's kind of cool as well. What do you notice about the derivative of this base curve, which happens to be a line?
It's the second point, or it's the vector v.
Yeah, it's the direction vector. It's this number here, isn't it? Well, in a way, doesn't it make sense? Isn't it a bit like the slope in a very vague way, whatever a slope means now? So I need to put together who f is going to look like using these three guys. So x take away y squared, does this take away that guy? So x take away y squared. Now, if you take away that, you get this guy. The middle term is y take away z squared. Y is this fella. Take away that guy squared. And then the last one is z take away x squared. And z is this fella. Take away that guy squared. Okay, let's tidy that up a little bit. That one's good to go. T, take away 1, take away 2, that's plus 2, that adds to 3, add t squared. So I believe you get a t squared, you get a plus 3t. No, you don't, you get a negative t squared, plus a 3t, take away 1. And this guy here, you get a negative 25t squared, take away a t plus a 1. I hope I did all of that. I'll just put underneath it r dash of t, just make it easier. You get 5, 1, negative 1. So we're just going to take this fella, dot product with that guy, dt. And oh, we need a start and finish t value, don't we?
Shouldn't it be 0 to 1?
And isn't it nice that if it's a line, it's 0 to 1 because the way we constructed the line? Now, that's going to be the integral from 0 to 1 of that guy times that, which is what, 25 take away 5t squared. That guy times that, which is what, negative t squared plus 3t take away 1. And that guy times that, which is 25t squared take away t, add t, I should say, take away 1, dot, dot, dot. It's just basically a quadratic integral from 0 to 1.
Why is it 0 to 1?
If you take the t to make that happen, it's 0. And if you take the t value to make this happen, it's 1.
Oh, okay, fair enough.
And the second rule is just a rule. If you create a parametric equation of a line using this technique, the start of the line will be t equals 0 and the finish point will always be t equals 1. And it's because the way it was constructed that that's going to happen. If you construct it this way.
In the integral, shouldn't it be 25t minus 5t squared?
Here? Yes. So, okay, dot, 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 that is just a big ugly quadratic. nothing particularly interesting about it, I think, after that. Let's go away from quadratics. We've done enough polynomials. Okay, got 15. In question 15, line integral over curve C. This time it's x squared y cubed. Take away the square root of x. I mean, this is a good question, but it is not one of the questions that we're focusing on right now. So let me hold that one for a while and I'll come back to that. Let's return to another one of these first. I wanted to focus on doing those, you know. This one, I don't think there's anything really weird going on. It's an x add y. It's a y take away z. And it's a z squared. And the space curve is t squared, t cubed, t squared. And now that I've wrote this question down, I don't want to do it. Would you agree that's just a plug and chug? We've done two like that. I mean, isn't that just going to be 2t, 3t squared, 2t? Aren't you going to plug that for x and this for y and this for z? And you're just going to end up with some massively big polynomial. So I don't really want to do that. I want to see if I can find one of our guys that doesn't have a log in it. I think we did 11. Is it okay, dot that one? Do you really want me to do it? I really wouldn't. No, good. I don't want to. Did I do this one? Oh, no, sorry. Scanned all over the place. Right, got it this time. I don't think I did this one. Does that look suitably new? Okay. It's kind of set up for us, which is nice. Right. So we're going to basically be asked to find the work done. And we all know that the work done means find that integral. Right. So sometimes they just ask you to find this integral. Sometimes they ask you to find the work done. But it's the same question. Where can we go? Well, it's going to be the integral from 0 to 2 pi. I'm going to turn this guy using these two fellas. See what we get. This fella becomes t take away sine t. And this fella becomes that guy add 2, which is that fella. Dot product. The derivative of this guy is 1 take away cosine t. And the derivative of this guy is 1 plus sine t dt. Right, this guy times this guy, that's going to be a t take away sine t, 1 take away cosine t. plus this guy and that guy is a 3 take away cosine t 1 plus sine t dt. Oh god, this one's got some stuff in it now. You get a t, you get a negative t cosine t, you get a negative sine t, and you get plus sine t cosine t. And this one you get a 3, and you get a 3 sine t, and you get a negative cosine t, and you get a negative sine t cosine t dt. Let's see what we can do here. Looks like that guy gets killed off by that guy. I don't think anything else really does much, so let's see what I got. I have a t, a takeaway t cosine t. Oh, these combine, so I get a plus 2 sine t, a negative cosine t, and an add 3 dt.
Hey, shouldn't the derivative of 1 minus cosine t just be sine of t? Because the derivative of 1 is 0.
Yeah, I fixed it by changing that. Okay, let's look at this. He's easy to do. He's easy to do. He is easy to do. And he's easy to do. How do you integrate t cosine t? Calc 2. How do you integrate t cosine of t?
Integration by parts.
Right? Make him f, make him g, dot, 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 dot. Right, so there's still a good 5 minutes left in that question, but you can finish it. So as long as you get a question that says, find this guy, and if they tell you who F and R is, then you're good to go. If they say, find the work done, and they give you this information, won't you just recognize that as just find this fella? Because this is the fella that gets you the work done. That's what it evaluates. Good. Right. Let me return now. This is us just tidying loose ends up. Let's look at 15. That's kind of a cool question. It's nothing to do with this guy, right? It's its own unique method. Let's take it one step at a time. Don't I need to find the parametric equation of this curve? And I don't need to do it in the form of R of t. In fact, it's probably in these questions a good idea not to use that format, just to use x equals y equals kind of thing. What would x equals and y equal to generate this fella? What parametric equation would generate a square root of x?
Would it be x squared plus or minus y equals some value? Minus y.
Oh, you're making it much more messier than it needs to. I'm not saying that won't work, but think a level down. Think simpler.
X equals t squared.
Yeah, just x equals t and y equals the square root of t. In general, if you get a function that is y equals f of x, and it's y equals x squared, y equals the square root of x, y equals whatever you like. In that world, that'll do the trick. Now, I have to figure out the t's, agreed? It's going from the 0.11 to the 0.93. What are the range of t's that would do that based on this fella here? What number should go here and here?
1 to 9.
0 to 1.
I hear 0 to 1 and I hear 1 to 9. 0 to 1 would be for a straight line joining 2 points, but this is not a straight line. In this case, you're going from there, which means 1 to there, which means 9. How do I know that? Because x is the same as t. So if x goes from 1 to 9, won't t go from 1 to 9? Right, so we've done that piece of the puzzle. So this integral will now become the integral from 1 to 9. X squared will become t squared. Y cubed will become this guy, cubed. Take away the square root of x becomes the square root of t. And now there's one last little fella that I guess I should deal with. And I'm going to use this guy to figure out what dy is in terms of t. So if y is this fella, won't we call that t to the half? Then if you differentiate y with respect to t, you get 1/2 t to the negative a half. If you do the crossover, dy is 1/2 t to the negative a half dt. So this fella up here, this dy, is 1/2 t to the negative a half times dt. Okay, and I got halves and square roots floating about, so I'm going to turn everybody into a square root. The square root of t cubed is t times the square root of t. You happy about that? And that guy's just a square root of t. Won't this guy be 1/2 square roots of t? If I take all of this and I pull out a square root of t, I get a t cubed, take away 1. You happy about t squared times that is t cubed root t, pull out a square root of t, pull out a square root of t, you get this? Since they cancel, and that's 1/2, and then it's basically just, you know, the usual integration techniques from 1 to 9. Are we good? Right, there are 3 kinds of guys that we have got. So for quick summary, we started today with those kind of questions, right? You then get the, well, whatever it is, x, y, dy kind of question. You can also get the xy squared dy dx plus xy cubed dy, right? That kind of question. That's what we just finished a minute ago. And then there's a third one that looks like this fella. Now you notice that they are quite different looking. So hopefully you can see the difference between this, this, and this. When you have a ds, doesn't your formula look like that. This ds is that guy. Now, in this question and in this question, don't you take parametric, whatever it is, and you replace all the x's with that, all the y's with that, and then you replace dy's and dx's, and that's how this one works. And in this case, all the x's and y's, dx by dt goes here, and dy by dt goes here. Okay, let me do that last guy then. Show you what I mean. Suppose you're being asked to find this integral, and you're told that the curve C is given in its parametric form as that guy. And you're going to do it from 0 to 2, right? So that's your question. Find this guy. Here's the information you're going to use. X is going to become t squared. Y is going to become 2t. The ds is going to become the square root of that guy squared plus that guy squared dt. So this is basically what ds is. Now let's see what we have. That times that is 2t cubed, square root of, right, if you want to get dx by dt, don't you differentiate this and you get 2t, and then you square it. And if you want to do dy by dt, you differentiate this, which is 2, and then you square it. So I'm now looking for the integral of 2t cubed times the square root of 4t squared plus 4 dt. Well, since this is going to be our last question, I'll give you a few moments to think about it. While you're thinking about it, say hi. Get attendance done. We have a major problem here. I think this is going to be a little bit different than you might have expected. We need to find the answer to this, and we have a limited number of things that we can do. Integration by parts, u-subs, I guess looking up tables, but it's not really an option. So one of those two is the only one that's going to get us out of this hole. What technique do you think you should use to find this integral?
You could use sub u equals t squared plus 1. And
Well,
then like mess around with what u equals to like plug that into the t squared.
Okay. Yes, that will work perfectly. Can I just do a slightly different version of it, but what you said is perfectly correct. I'm just going to use the entire square root. That. Right. Now, if you make that your u sub, then du by dt is 8t, and that makes du 8t dt, and that makes that fella dt. So we have the integral of 2t cubed square root of u times 1 over 8t du. And the t's cancel and that gets you a quarter, so I'll pull that out. And now you are left with something that doesn't look good, but it is fixable. Don't we have a t squared left over? But you can't have t squares left over. Doesn't everything have to be turned into a u? So we got to figure out how we're going to do that. And the only thing I've got to work with is the U sub that we started with. Is there a way to use that to find out what t squared is?
U or t squared equals u over 4 minus 1.
Subtract 4, divide everything by 4, which I'm going to call a quarter u take away 1, which means that this thing is 1/4 the integral of 1/4 u take away 1 times the square root of u, which I'm going to call u to the half. What do you think I'm going to do next? You've got to do something.
Integration by parts.
I
Or you
can
could
see
just
the
combine those
temptation
powers.
to do that, and that would actually work, but there's a little bit less, an easier way to do it. Let's just say that,
Distribute the u to the half.
right? But you're quite right. Integration by parts would work, and it doesn't mean that you wouldn't get the right answer, because you would. And I don't know, I've got fractions. You can't win with these darn things, so I tell you what, I'm going to just bring it back in again. It's not like I can avoid them, right? Would you agree that's just a really ugly power rule? And then once you get the answer, replace the u with that guy. And then you can plug in 0 to 2 and you're finished. And that is perfect timing because we have now finished line integrals. Any questions before I go? Then good luck with your homework. Maybe I'll see you tomorrow and you might have questions. Bye-bye.
Thank you.
You're welcome.